Okay, so let's get started. We're going to be taking a look at how to set up and work with a flex fuel sensor within our Link G5 and G4X programming. Now, a flex fuel sensor is going to allow us to tell the Link how much ethanol content is within our fuel system. This is important because as our ethanol content changes, the amount of fuel that we need to inject into the engine to reach a desired target lambda target air fuel is going to vary substantially. So if we're on pure petrol or 0% ethanol, we're going to have a certain amount of fuel that has to be brought into the engine to hit a desired lambda air fuel. And then if we're on 85% ethanol, we're going to have about a 30% increase in our injector pulse width and fuel flow rate to achieve the same desired target air fuel target lambda. Now, as our ethanol content changes, the Link's going to have the ability in the flex fuel option to be able to account for the ethanol content and be able to correct our injector pulse width and fuel flow so the engine runs correct in terms of our fueling delivery based on whatever the ethanol content is going to be from 0 to 100%. We're going to get into how to set up and tune flex fuel much later in the training course, but we want to learn how to set up a flex fuel sensor now to get this out of the way as we're configuring and setting up our inputs. And when we're talking about a flex fuel sensor, we're going to have 3 wires for that sensor. We're going to have a power supply, we're going to have a ground, and then a signal. Now, the power supply, we typically run this to a 12-volt power source in the vehicle. So this is coming somewhere from the chassis. I like to make sure it's a key-on 12-volt source when I'm supplying the power source. The ground technically needs to go to a signal ground. However, some sensors seem to bring in some noise to the Link when we do sensor ground them. So you may have to alternatively chassis ground the sensor. It's really going to depend on the specific sensor that you're working with. But I always first try to go in and run them to a sensor ground. Now the last thing we have then is the signal wire, and that's what we're wiring into the Link. The signal wire is going to be broadcasting a frequency signal to the Link, 50 hertz to 150 hertz range. And that's going to change the frequency it's outputting based on the ethanol content. So at 0% or pure petrol fuel, 0% ethanol content, that'll be broadcasting 50 hertz. At 150 hertz, that'll be 100% ethanol. And anywhere between those two, it'll be a linear increase in that frequency output based on the ethanol content. Very, very simple on how it works. Now, we're not going to be using an analog input for setting up a flex fuel sensor. So when we're talking about pressure sensors or linear position sensors or temperature sensors, we deal with analog inputs in our analog input window here, as we talked about in the last few training modules. Now we're going to be jumping into digital inputs. When we're talking about an on-off toggle switch or a switching type of function or anything that's going to provide a pulse type of input to the Link, we'll be dealing with a digital input. When we're speaking of frequency in terms of the ethanol content sensor, that will be a digital type of input. Let's jump in and take a look at where we can find the ethanol setup window and then go through and actually configure this. So jumping in here, I have a digital input window. Let's jump all the way over to the digital input. Within the window here, we have a lot of different functions that are already assigned in the software. What we're specifically looking for is our window here called ethanol sensor. We can see right now the source is set to none. Now, I know where I've wired my digital input from my flex fuel sensor to the Link G5, which is going to be found on digital input 2. You definitely need to know where you're wiring it to so that you're able to assign the correct source. So what I'm going to do right now is go in here to source, and I'm going to go ahead and assign that to digital 2. Let's go ahead and assign that. The next thing we're going to do here is go up to our pull-up resistor, and we absolutely want to have this on. We need that pull-up resistor for the circuit to work. Now the other thing we have here is our active edge. When we're dealing with a typical Continental sensor, which is the sensor that Link's going to also sell, we want to set our active edge to rising. Now, this is going to be important in terms of the edge. We're talking about falling and rising. We'll find in a frequency signal, it's going to be sending a pulse in a frequency type of format. We're talking about frequency, it's a certain amount of pulses in an elapsed period of time. So 50 hertz versus 150 hertz. 50 hertz is going to have less pulses in that sampling time compared to 150 hertz. The active edge in terms of falling or rising, when we're speaking of a frequency, it's typically going to be going from 0 to 5 volt, and it's going to be pulsing up and down. So we'll have, in case of 50 hertz, 50 0 to 5 volt pulses in a sampling time. Or if we're talking about 150 hertz, we'll have 150 0 to 5 volt pulses in that sampling time.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.